Hey there, and welcome to my talk, Tests That Help You Find Defects Faster. My name's Philipp, but everyone just calls me Phil, so you can do this as well. I live in a town called Potsdam in Germany, right next to Berlin, but except for hipsters, we do have castles. I'm also a CTO at a company called Auteon. And I've been in technical leadership roles the past years, and I've mentored a couple of less experienced developers along the way. And while doing so, I learned about different mistakes different people make, about some troubles people put themselves through when they write tests for software. And since I enjoy writing tests a lot, I'm a huge fan of TDD because it just helps me organize myself and work in small steps. I thought this is a nice opportunity to share some of that knowledge. Obviously, I've made most of those mistakes myself in the past years, often enough to kind of dissect them and look into what's really important and whatnot. Which brings me also to my first point. So I'd like to start this talk actually not with some topic, but with the topics that this talk won't be about. And the first thing will be naming tests, right? So there are a couple of different styles how you can write test names, test descriptions. Just to give you an example, just going to run those here so you see how they look in a test runner. There's, for instance, one style called RSpec, where essentially you read through all the describes down to the it, and then this forms a whole sentence. So for instance, here a user can be identified, right? This is one way of doing it, obviously, right? There is also a different style, BDD, behavior-driven development. This is where you see the keyword should a lot. So here I've used user just merely as a name for a group. And then the test name itself is should be possible to identify a user. Now, the important point here is, both are equally good, right? There is none, the one isn't better than the other. It's just a matter of personal taste, what you like better, what works for you. This is also why I don't want to make this an issue here. So in this talk, I'm going to use the BDD style a lot, should, but, I don't think it's the better one. If, you prefer to write your test differently, that is absolutely fine. So this is really not what this talk is about. The second thing this talk isn't about is about certain arbitrary rules when it comes to how many assertions should be in one test case, right? There are lint rules out there that say every test should only have one assertion in it. And I don't think this is necessarily always, right, correct. So for instance, these two are exactly the same. The first one uses one assertion where, we want to assert that a user object has a certain structure, so we can use to match object to match against all those properties. And if something should be missing, then it fails. But we could write the exact same test also with two assertions where we check for the properties individually. There are probably, there are pros and cons to either of this approach and either of these approaches. But I wouldn't say, one is particularly better or one is worse. So also here, this is not something I'd like to talk about. Figure out something that works for you and go with that, right? And obviously, so what this talk is also not about is, hopefully, is nitpicking my examples. So I've chosen deliberately simple examples to get the general idea across. They're obviously not from the real world, right? You probably wouldn't find them exactly like that in a real world scenario. Sometimes they might even contradict certain rules that I say, but then always just to get the point that I'm currently talking about better across. Okay, with the playing field leveled, let's dive right in. And essentially, I've structured this talk into two separate parts. So the first part focuses on general structure of tests, like how to organize everything. And then the second part is, how to really write tests and, two common pitfalls people fall into. So let's start with the first thing that I see happen a lot. And also let me just point my test runner to that. And this is, while I don't think there needs to be only one assertion in a test, what I do think is that each test should cover exactly one use case. And this is a mistake you can super easy make. So for instance, here, the test description, and really just focus on the test description here, is it should be possible to read from and write to the database. Now, and we see this test fails. If I'd ask you now, like, what is it? Like, is it the reading part or the writing part? You probably couldn't just, tell from the top of your head, right? And also, if you're working, on your software and this test, starts going to red again, you also need to figure out, like, which part is it that you just broke, right? And my general rule of thumb here is that whenever you write the word and, A-N-D, into a test description, just make it 2 tests, right? You're combining too much in there already, which shouldn't be combined. So what can we do about this? We can split it up. And let me just point my test runner again. So now we got 2 tests. One, it should be possible to read from the database. The other one it should be possible to write to the database. Now, if the second one fails, we know, okay, it's definitely going to be the writing part that's broken, not the reading part. That's nice because already from the test failure, we can see what's going on. However, there's one little small improvement left to be made here. So what happens, for instance, if both fail? Because here we can see that use cases aren't necessarily only, like the keyword "and" isn't the only thing you need to look out for. Now, if you think about it, like what do both reading and writing to the database need? A connection to a database. So if both fail, it could be that there are separate issues. It could just be that the connection isn't working. So this would be the last improvement I would make to this. Add a third test that just looks for the connection. So if the connection test fails and the reading and the writing, okay, it's definitely going to be the connection. At least there is an issue there. And it's very likely that this affects also the reading and writing specs, while this isn't as clear if you don't have that spec. And some of you now might be thinking, if you do TDD, this is something that would, like this structure comes really naturally. Because if you start building this interface, you definitely would start with, ensuring that there is a connection to the database. So this would be the first test you write, and then you would add other tests after that fact. However, even if you do TDD, sometimes you get carried away, you want to get something done, and this is when you start cramming multiple use cases into one test, but this will bite you in the ass down the line. The second thing I'd like to talk about when it comes to general test structure is the use of assertions, right? And the pitfall you can make, or you can trap into here, is that essentially we can express everything as a Boolean expression, and make it a true or false check, right? And I've started here, just skip that second test for now. I've started here by checking whether a certain property on a user has the correct name. Let me just point my test runner to this so we can see it fail. Now, if that test is fine, right? It checks for the correct thing, right? It just does it in a way that if it fails, it doesn't really tell us what's going on, right? So here we can see the test runner just tells us it expected true, but it received false. So now, what does that mean, right? This forces us to open up the editor and navigate to the test file to figure out what's going on here. However, we can do better. We can, for instance, use the assertion to have property, tell the thing, and make our test look like this. So now we're expecting that a user object has a property called John. Right? And now the error message looks slightly different, right? First of all, it tells us that it's looking for a certain path here called name. Then it tells us that it expected a value called John, but it got Jane, right? And what this gives us is context, right? So this doesn't just tell us that the test, which hopefully has a nice name, fails, but also some context to why it failed, right? And this then again, helps you understand faster, what did you just do? How does this relate maybe to this error? So that you can figure out what might, be causing this, what did you change that causes this error? And for this, let me just turn this around. Common thing or something we can do is, for instance, test for errors, right? So for instance, sometimes you throw exceptions and you want to make sure that the correct exceptions are thrown. You can do this way, right? So you have your code, you call the function that you expect to throw, you catch the error, and then you do some assertion on the error message. And here, for instance, we just want to make sure that it's, some part of that error message, because errors, also add some standard front. For instance, an error colon, and you just want to make sure that your error message is in there, right? And we can do this, with an index off check, and then, we don't want it to be -1 because that would mean it's not in there. However, again, that error message expected not -1 doesn't help us a lot. Again, luckily for us, Jest, as a testing framework I'm using here, offers us an assertion that we can just pass a function that we want to throw and expect it to throw with a certain message, like with a certain error message. Now, again, the error output looks slightly different. First of all, we see what we expected. We now see what we received instead, custom message. And also it points us directly to from where the error that was thrown. And this can, once again, give you more context to work with your code and then fix that error, hopefully. There is, probably a lot of you are working with DOM. Some of you might be working with testing library, and there are super nice additions to Jest. Jest DOM is one if you're working with testing library that just give you a bunch of custom assertions to check for accessibility attributes, for UI states like disabled, enabled, focus, and all this kind of stuff. But it all falls into the same category. Like, my general suggestion would be, pick the assertion that is closest to what you actually want to do, like, whether you want to check for a property, whether you want to check for an error, whether you want to check for a certain UI state, and then go with that, instead of, just building some form of Boolean condition and then checking for that to be either true or false, because that won't give you much. Okay, so this essentially concludes the first half, right? General structure of tests. We talked about assertions and test descriptions, and especially, only working with one use case at a time. Now let's look at some test code, right? For instance, this test, perfectly working. However, there's a lot going on in here, right? So essentially, this test just checks that if we change an input, that our on-change handler was called with the correct property. But we have a lot of setup. We have lots of interaction going on down here, and the question I would ask is all of this interaction necessary? And it could be, right? And if it is necessary, then instead of just spelling it out here, I would go ahead and extract that, for instance, into a method. Call it, for instance, simulate change, which has a value, and then I can just move this here down there. Call simulate change instead. So now the whole arrange, act, assert structure of that test became much cleaner, right? And also this has a name, right? We want to simulate a change because this is what this block was all about, right? Now, by extracting it to a method, giving that method a proper name, we can just make this clearer to the reader. However, I see much more. For instance, there's an on key down, function defined here, and it's passed along, but we never assert on it. So my question would be like, how important is it, right? And this, this can happen, especially if you copy paste tests a lot, because this might just, was important in another test that you copied this from, and you never took it out, right? And by, repeating this, you can blow up your test cases one after the other, which is why personally, I always, write out tests from the start. I try to, not copy and paste at all because I'm lazy. And my laziness will force me to write the least amount of code and also, start extracting into methods as soon as I, repeat the same structure for the second or third time. So I use my laziness as a forcing function for nicer tests, essentially. And also, given that, let's assume this was written with red-green refactor. So the test failed in the beginning, then we implemented something, make it green. Now we're in the refactor phase anyway. So essentially, any change we can make to this test that keeps it green, except maybe for removing the assertion, is a valid change, right? So here, for instance, I could say, let's just remove the on key down, and then see what happens. Yeah, so it's still green, and we can also remove the initial value here, because that's also, I don't think it's important. Let's see, right? Let's figure out whether it was important or not. Nope, doesn't seem so. And just to prove it to you, if I remove the onChange here, test still type checks, but now it should fail. Yep, now the test fails, so that apparently was a change I should be making. Okay, so with that in mind, the lesson to learn here is, keep tests as small as possible. However, and this brings us actually to the last step, is one thing, I did also by extracting this is, like if this is, if this part of the code would be present in multiple tests, then, I would adhere to the dry principle. However, dry can be dangerous in tests, and let me show you why. So, and let's look at this last example here. So, essentially these two tests, the one checks that, on-click property isn't called when a button is disabled, and the other one checks that it is called if the button is not disabled, right? And these tests look a lot alike, right? However, if we look at the render, then we see that this one passes the disabled prop, this one doesn't. Clicking the button is exactly the same code. However, it's already minimal, so maybe not, doesn't make sense to extract that. And then the assertion also slightly different because one has a not in it and one doesn't. So, however, the on-click method that we define here is, this line of code is the same in both test cases. So you could be tempted to keep those tests dry, to move it out of the test, remove it here, save, and we followed red-green refactor. So if the test stays green, everything is fine. And the tests stay green. So this change must be a valid change. However, we made one big mistake. And the mistake we made is we just coupled those two tests. And we coupled them by extracting this, because this is something that is mutable. There we have it again, shared mutable state. The line is the root of all evil. Right, so in this case, by extracting the on-click handler, we now essentially we coupled both tests to it, and even worse, the order of the tests all of a sudden is important, because if I move this test below this one, then look what happens. It starts to fail. However, it doesn't fail because the code isn't working. Right? It just starts to fail because, this on-click handler here, starts counting. And it has been, when the first test runs, on-click handler is called for the first time, it stores this. And then if the second test runs, then this assertion is not true anymore, right? So because it has been called in this test. So we coupled our tests, they're not isolated anymore. And these bugs are really, really nasty to debug, right? Because, if you start, if I single out this test, right, it will work again, right? And this is, one of the most frustrating things I'm doing. Like if I look at a test fair, I put an only somewhere, and then the test starts working, and it's like, damn. Because then I essentially have to really dig into the code and figure out, okay, what's going on? Like, where is the shared state? Where, how can I make it not shared and take this apart? So my general suggestion is try to, certain wetness of tests, I think is good, right? And just to avoid these kinds of scenarios here. And this almost concludes my talk. So just to recap, what are the 4 important points to learn here? So first point is, try to stick to one use case per test. This is really important. One use case does not mean one assertion, just, one use case. then try to use assertions that match really what you want to express, right? So that if an error happens, the error message delivers as much context as possible for the particular thing you were testing. Then, when you write your tests, maybe don't copy paste too much, right? Keep the tests concise and keep them to only what they really need to, perform their work, right? This helps you, should you need to dig into the test code, to not be distracted by everything else that is there that does nothing, right? And the last thing is, don't try to be too dry with your tests, because test isolation is more important than, completely dry code. Every test needs to work on its own and shouldn't rely on something shared global, because that just, comes with a lot of danger and hard to debug errors. That's it. Thank you very much for listening, and see you in the QA. Bye-bye.